morning to all. Myself, I am Dr.S.Kalaiselvi, Assistant Professor of Maths, Standard 5 Rocks Rajaratnam College for Women. Now, in this class, we are going to see about the conformal mapping, which is one of the analytic functions. This conformal mapping is a function defined on the complex plane. In this class, we are going to learn about the conformal mapping to what is meaning by conformal mapping. Then conformal mapping is a function in the complex plane, and a map W equal to f of z is said to be conformal if it preserves both the angle between the curve. These are the curves. First one is in Z transformation and second one is the complex plane transformation. In this we are going to see about this mapping. First let us know about the conformal mapping. It is also a transformation in a complex valued function which transforms a given curve or points on a plane preserving each angle of that curve. In this angle we are going to map the curve. Next, what are all the conditions for conformal mapping? First, let us know about the sufficient condition for a transformation. That is, the W equal to f of z is said to be a conformal mapping if the function is to be analytic function in a domain D of the plane Z. First, let us take the function W equal to f of z and f dash of z, the derivative of the function inside the D is not equal to 0, and then the mapping W equal to f of z is conformal at all points of D. This is the sufficient condition for the function is said to be conformal. Next, let us know about the necessary condition. The necessary condition for a transformation being a conformal mapping is for the same function W equal to f of z, which represents the conformal transformation of a transformation D of the Z plane into a domain D dash for W plane. That is the transformation from Z plane to W plane. We should know about the function is said to be analytic function of Z in D dash. These are the conditions for the mapping is said to be conformal mapping, which is sufficient and necessary. Next, let us know about the function. That is conformal function. We know that it is a complex plane which transforms a given curve or points on a plane which is preserving each angle of that curve. If f of z is a complex function defined for all z, that is W equal to f of z is said to be a transformation. The transformation is transform the point z equal to x plus y in Z plane, and in V plane it is W plane is represent as W equal to u plus iv. If this transformation preserves both the angles between the curves and both in magnitude and in sense. That is, the sense means we can know about it is positive or negative, that is in counterwise or clock counterwise. Then the mapping is said to be a conformal mapping. In this we know about the isogonal mapping also. If there is a transformation, that is the mapping is only for magnitude of the angles between the curves, they are identical, but it is opposite in direction. First, if it is positive, then its counterpart is negative. If it is negative, then counterpart is positive. In that case, the transformation is said to be isogonal. Next, let us take an example for the conformal mapping. This is the region is a rectangular region. It is in Z plane. The rectangular region is bounded by the curves x comma y equal to 0 and x equal to 2 and y equal to 1. The image of D under the transformation W equal to, it will transform into the Z plane as 1 plus I and 1 plus 2i. It gives also the rectangular region D of the W plane. Then the value of u plus v equal to 3 and u minus v is minus 1. In the same way, u plus v equal to 7 and u minus v is minus 3. In this also the isogonal mapping is also defined as the isogonal mapping. Then the conformal mappings is having a critical point. What about the critical point? Means in this critical point the function w equal to f of z is a non-constant analytic function in the same region D, but in some point z naught, f of z naught becomes 0, then this z naught is called as the critical point of the given transformation. For example, if we have z equal to 0 is the critical point of the transformation w equal to f of z, where f of z means 2z cube minus 1. It is also noted that the constant map has no critical points, then at a critical point the mapping is not conformal. This is one important point of the conformal mapping. Next we see about the applications of conformal mapping. Conformal mapping helps in producing low flows of a ideal fluid when the flow is two dimensional with no trade off in the laws of fluid mechanics. By conformal mapping, a region of interest to simpler region with exploitable symmetries, and we are able to solve increasingly difficult electrostatic problems with minimal effort. In the electromagnetic problem, we are able to find the equations of motions also. Then in mathematical theory, the conformal mapping gives a area theorem by the power series coefficients of certain conformal mappings. Then a large number of problems arising fluid mechanics, electrostatics, heat conduction and many other physical situations can be mathematically solved by Laplace equation using this conformal mapping. In here we are giving the Laplace equation as pi xx plus pi y equal to 0 in the region D of z plane. This pi of x comma y, in addition to satisfying this equation, also satisfies the boundary conditions on the boundary C of the region D. Then the theory of analytic functions, the real and imaginary parts of analytic functions also satisfies this Laplace equation. Followed by this, we are able to find the function which is analytic in D and satisfies certain boundary conditions on the given complex plane C. Then the solution of this problem can be greatly simplified in the region D is either the upper half of the z plane or the unit disk. Some more applications are there. This is a vast area of conformal mapping. Thank you. Next class we are see about the analytic functions. Thank you one and all.